rest was just dying. Here they are going in dry. They'll take about 15 minutes to warm up and 10 minutes to bake, so I'll come back in about half an hour. Okay, it's been half an hour. Let's see what we got. All right. It's pretty hot, but I guess I can show you one. Yeah, that's just come out at like 200 degrees, so I can't handle that for very long. I might put that on the washing line. For the JFET buffer, I'm using an MMBF 5457. That way I know it's a genuine part. Next part in are the silicon clipping diodes. Back to back, I'm using a 1N4148, which is the modern replacement for the 1N914. It's the same part with a higher current spec. And notice the glass body actually sits them up and stops it from shorting against that trace there, so that's intentional. It looks kind of sus, but it's not. Oh, and also my thumb is growing back. Next parts are some power management diodes. They got some hefty leads, so I'm going to upcycle that later. And the 30 picofarad ceramic, I've opted for a multi-layer ceramic so that I can get the 30, not the 27 or a 33. It's a bit of an irregular value. This is actually a multi-layer ceramic capacitor. If you ever see these axial sort of packages, it's just a multi-layer chip inside with legs stuck on and in an epoxy body, so you might as well just use an SMD chip. Multi-layer ceramic capacitors sometimes get a bad name. They're actually pretty cool because as the voltage applied goes up, the capacitance goes down on them, but the potential on each side of this is going to be the same, and the voltage applied is only the signal, which is very small. For the other ceramics, I'm using these ugly, common, cheap 1 kilovolt dielectrics, so it's very low ESR. Don't usually use them, but I'm just going to chuck them in. I think they'll look good. Nice and old school. Next parts in are these green bobbin looking things. They're actually an inductor, not a resistor. This 1 meg is used for bias. It's a metal, so it looks a bit different. Next, these carbon comps have a very special job to do. I'm going to stop putting resistors in and solder what's here, because if it gets any more congested, I might have trouble getting my soldering iron around. So I'm going to take the resistors in 2 shots. Now I'm going to cut these legs off. These are actually valuable to me. I use the offcuts even for the smaller builds to wire up the foot switches, and sometimes I actually run out of these, so they don't go to waste. These ones, for example, they're a bit longer, so they can be used to connect the audio sockets, and some of them I've crimped a little bit. That's just a little indicator to me to keep them separate. So the original used the National Semiconductor LM308, which is now obsolete. Is a particularly unremarkable chip, but people trying to find them now are going to get relabeled duds, things like that, or no one's really reproducing because there's no demand for it. So I'm using an LM308, so it's still National Semiconductors. It's the AH package. H means the metal can. So if you're going to buy new old stock parts, it's good to get the original packaging. That way you know you're getting something legit. And there's less demand. People haven't been searching for these metal can packages, so yeah, I'm confident I know what I've got in my hand. And I don't have many of them now. There's a little notch marker here. You might think that indicates to put it in the square pad for pin number 1, or maybe it might be earth or something. This notch is actually just indicating pad 8 sort of randomly, and I've got a little notch marker there on the board to remind me where to put it in. If you ever tried installing one of these, it could be pretty fiddly. It's sort of like get one leg in at a time and go around the circle, and you know, one might pop out as one comes in, or you might have started on the wrong pin. Oh, there we go. Everyone see that? Even with people watching. Look at that. Cool, huh? It's time to deal with those 2 disc ceramics. This one, the spacing isn't 5mm, so I'm just going to have to sort of hold it by hand. And this one too, I want to make sure that insulated bit doesn't go into the via or the via, so these are going to sort of get a bit of hand attention. And see, they're the next highest sort of component above the op amp level, and then I'll work my way up to the larger caps after that. For the 3 and 3, yeah, I've got some polystyrene caps, and that's going to be a part of the tone network. I've got these polypropylene caps for the 22 nano axials. That's another one where the legs are really good to save. In the future, I probably won't have these polystyrene caps for this build because they're obsolete from the manufacturer. It's good to use polystyrene there. Very linear underneath polypropylene only just, but they're very accurate, and they're accurate over a very long time. Like, you can pick up styrene caps from your parents' age and they're still like precision devices, so these will outlast the device and probably even you. The electrolytics are going in, the 4.7, the black one there's a Nichicon, I think they're obsolete. And the rest are Panasonic M series, so all high quality Japanese caps. 1 microfarad, this one here with my finger, is a polypropylene, so that's the output capacitor. Oh, there's more in here. The germanium clipping diodes are in. The original layout I drew years ago used a smaller diode, so I had to pop these ones upright. And that black enamel, whatever it is, insulation at the base there, some of them I had to like pull it out quite a bit to not be in the via. Alternatively, I could have maybe scraped it off with a razor blade, but there was 20 of them, so they feel pretty strong. They're not really stressing the board. Yeah, I like it. I've got 5 OC42s. They're just the right range for what I'm after for the germanium section. Alright, all the germaniums are measured up and loaded. I actually really like using germanium because it's such old technology. You can usually get it really cheap, like cheaper than silicon, like on eBay and that. So yeah, it's good to like do a service and recycle. Use it all up. There's a tiny bit of overspray there, but when the audio sockets go in, they're going to go in with a serrated style washer. The board's prepped, ready to install. That lead there is just a clipping off the diode. These leads are clippings off the 22 nano axials, and these leads are clippings off the 1 watt resistors, all getting upcycled. Box I'm so happy with. So it's a Hammond 1590 N1. Hammond's a really good alloy to drill. Powder coated, so it's stronger than any professional paint by just a mile. And UV printed is the toughest way I know to get graphics on something, so it's rock solid. I love it. The color, I could never imagine using this color. Like, I bought this, I found on eBay 2012, so what's that, 13 years ago now. It's just such a loud color, I didn't know what to do with it, but for a rat, you know, like an 80s loud, it works. And with the negative, like inverted artwork, been meaning to do that. Yeah, hopefully I can do more of these in the future. So I put this together for the LED. My mother gave me like 1,000 of these. They're an old stock. You have to peel the glue off it. But yeah, let's put it together. So here's a tip. You put the pot in, you got the knob, great, but it sits all the way up there. That looks terrible, and it's actually like really weak. So my solution is pack out the inside. This one I've got an extra washer and an extra nut. Hey, look at that. It looks professional now. So I'm not putting a washer on the top. There isn't much thread left. Last look inside the enclosure before the board goes in. Make sure not to squish that battery lead down with the pots. There's a little bit of excess sort of tucked up in there, so customer can yoink it out. And that's sort of just tucked away. I'm not too worried about it short-circuiting against anything. This doesn't carry any positive power if something's plugged in, and if nothing's plugged in, then it's still not carrying positive power. It does carry earth, which might short against earth. Again, that's not a problem. Okay, here we go. This is the fiddly bit, eh? The alternative is you could put all the pots on the board and then drop all the pot heads in. Pot shafts, whatever, I'm not thinking. But this is gonna work, come on, there we go. So that's all aligned, all my drilling was okay. I've over drilled this switch a little bit because there's always a bit of margin for error, and I didn't want to stress out the terminals. But that's gonna as that tightens up, that's gonna register in the center now anyway. I can tighten that up. You have to be super careful because there's not much to grab onto, and it's very easy to slip and like leave a grind on the enclosure. There we go, silicon mode or germanium overdrive mode. Fire up the soldering iron. We can get cracking on the soldering, and then it's, oh my god, look at those colors. It's already looking like fire. Neon red orange. So I just want to stress that I never solder the hardware to the circuit board and then pop it into the enclosure. Even if I had a jig or something, each one is soldered in its final resting place to match the enclosure. So this board is going to marry up. Like my drilling's fine, you can move it across to another board, but those fractions of a millimeter here and there, you know, that's how pads get stressed and hardware gets stressed, and like you get cracks in boards and switches, and this is going to be minimal stress, and for the life of this pedal it's all going to match up really nice. I might just do the old school and blow the fumes away. make that just a tiny bit shorter, not much. Fold that around. These I'm going to make shorter by about that much, maybe a little more. And they have to match. And then it's just a matter of folding those in. And if you make a similar action on both leads, they should sort of form in the same way, like they'll look uniform. This is circuit out. And when I solder that, I'm very careful not to accidentally touch those diagonal link wires. I can touch this Teflon though, that's impervious to heat. Now that everything's sort of seated, I can get that LED in. And I'm probably not wanting it to stick up out of the enclosure much, like worst case scenario, say someone pushes in with their finger or something. So just about there, looks pretty good. What I might do to keep it looking neat, I'll solder one leg, or solder, wherever you are, and then I'll cut the two, and then I'll come back and resolder. This is an old LED, it's got leaded soldered legs on it, so I'm putting them in my e-waste bin. It's a good time to scrape any of that, just a little bit of black scoring there from the flux. Before the hardware goes in, you don't get any flux blobs off the side, but I actually don't see any, so make sure there's no debris in there, which I would have picked up as I did it, so there isn't any. Chuck on a 1/2 inch socket, even if you are in a metric country. So that's the serrated star washer. This is the input socket. It's a stereo socket, so that the jack plugs in, it shorts out, and sort of works like a power switch. That's why pedals turn themselves off when you unplug the input jack. When you unplug the out, when you I haven't tightened that up all the way just yet. I'll show you why. See, I've actually over drilled these with a tiny bit of slack, because when you drill on you get the pedestal base, and it's like you're already on a bit of an angle, and then you're drilling on another bit of an angle, you get a little bit of drill creep. Even if you've got really sharp tools and you're holding it really well. So what I like to do is over drill a tiny bit. Plus, the other reason I do it is because it's a metric drill size with an imperial part. But this gives me like a little bit of flexibility to make sure that the heights are matching and like everything's not shorting and stuff, which it's not. So I just tighten it up at the last moment. This mono one, you can I sort of try and rotate it so it looks nice and symmetrical and neat. So it takes a little bit of thought maybe. And I've just sort of nipped that up, and I can feel it binding and making continuity between the enclosure and the jack. So that's my earthing point, sort of my star point is here. I consider this one little jack here the main sort of source of all my ground negative earth enclosure. And that carries across to the output. I don't bother wiring up the earth because it's making a link right from here to there. So adding another wire from there to there, it would be an earth loop. It wouldn't be a negative earth loop though, like it wouldn't hurt it, but it also just doesn't seem necessary to me. Moving forwards, so I'm going to bend these over now. I'm not pulling very hard, like I don't want to put exertion on the actual board. It's just like a soft bend, and it's like there's even a little bit of slack in there. Like if someone took the board out one day, it's not stressed to the max, it's got a little bit of give. It's not very good when you pull everything really hard on everything else. Okay. I'm gonna use gravity on my side, tackle this from underneath. That was a little bit hard with the box jumping around. So it's overhanging by a little bit, that's okay. Oh, didn't fill the hole. That's still in. Come on, there we So by wrapping it around, you're also exposing the amount of surface area that's getting solder, so that's a win. This is the earth wire. Like I said, I consider this the main sort of star grounding point here. This is where the circuit joins the chassis and also the power supply negative. Being an earthed terminal, just takes a little bit of extra heat to sort of get the solder to go where you want it. And this is a link that comes up from the DC socket, carrying negative. And I don't do a mechanical wrap on this one because I just clip it off, because that's another one that if someone ever wanted to take the board out, this and the puzzle, you'd have to desolder them or just clip them off and put a new one on. So thank you. I was gifted one of these, and the idea is you put it underneath and it orients the knob. But my issue with it is it's a little bit too thick. It doesn't even fit under the knobs. But I've got a trick. I just do it by eye. I've done thousands of these. I get them all on loosely. And I get the grub screw to a point where it's only just binding, and then I turn them all one way. And I'm trying to aim to stop at about the 7 o'clock position, if it was a clock. And how's that looking? That one I think I overshot a bit. Let me fix that. Start again. Yeah, they all look good. I'm going to tighten them up. So I'll show you when I turn them the other way, they should look about right. Let's see how we went. Yeah. Guys, thank you so much for sticking with me through this build. I'm so happy with how this has come out. It's kind of just as I imagined it, and it's really beautiful. The circuit itself is tried and true. I've built, so many of these. I know exactly how it sounds. So there's lots of videos on the internet. Here's some of the goodies I'm going to send. I have to sign off. I sign my name inside. There's a minimum 10-year warranty card. Guitar pick. This bag I printed earlier on the UV printer. And yeah, if you're interested in my stuff, check out my website, social media, all that. I've got super simple returns policy, and stay rad.